Partitioning, ranking, and tie handling are central to business intelligence and analytics. Showing you understand the difference between window functions is the primary signal for senior database capabilities. Filtering the top n elements within a group is a classic database query. For this challenge, we must find the top 3 unique salaries for each department. While this sounds like a straightforward lookup, a naive approach using correlated subqueries will collapse under a severe O of n squared execution tax. Let's analyze why. Here is the trap: using a correlated subquery to count distinct higher salaries. For every employee, the subquery scans all other employees in the same department to count how many have a strictly greater salary. If the count is less than 3, the employee is selected, logically correct, but an execution disaster. Why is this approach slow? The inner query cannot be pre-computed. For n employee records, the engine performs n nested scans, resulting in an O of n squared time complexity. Additionally, using count distinct inside a correlated subquery fails to scale when groups have duplicate salaries at the boundary. To write optimized SQL, we use window functions. Specifically, we partition our employees by department ID, order them by salary descending, and apply dense_rank. This assigns the same rank to identical salaries without skipping numbers. The query engine performs this in a single pass sort, executing in O of n log n time and O of n space. Choosing the right window function is vital for correct tie handling. For a salary list of 90, 85, 85, and 70, row_number assigns arbitrary ranks 1 through 4, dropping one of the ties. Rank assigns 1, 2, 2, and then skips to 4, failing to select 70. Dense_rank assigns 1, 2, 2, and 3, selecting all 4 records correctly. Lock in this window blueprint. Correlated count aggregates run in O of n squared time. To optimize, use dense_rank inside a CTE for O of n log n execution. Always verify tie handling rules to choose between row_number, rank, and dense_rank. Master this blueprint, and you will ace your ranking and partition loops. Let's analyze the correlated count distinct approach. Time complexity, O of n squared. Space complexity, O1. For every employee, the subquery scans all other employees in the department to count distinct higher salaries, triggering O of n squared execution. Let's analyze the dense_rank window function approach. Time complexity, O of n log n. Space complexity, O of n. Performs a single-pass sort partition scan to calculate ranks, running efficiently in linear logarithmic O of n log n time and O of n memory. The interviewer will then ask, what is the difference between row_number, rank, and dense_rank? Row_number assigns consecutive integers starting at 1, ignoring ties. Rank assigns the same value to ties but skips subsequent numbers. Dense_rank assigns the same value to ties and does not skip any numbers. The interviewer will then ask, how would you find the second highest salary in a department without window functions? We can use a subquery to find the max salary, where salary is strictly less than the max salary of that same department, or use a self-join. The interviewer will then ask, how does the database engine physically execute a window partition and sort? The engine first reads the input dataset, partitions the rows into buckets in memory based on partition by, sorts the rows within each partition bucket by order by, and then runs a single linear scan to apply the ranking function.